Hello, welcome to another video of Code Snippet. So in this video, we are going to look into another important aspect of Spring transactions, transaction propagation. So this is basically the part 3 of the transaction series. In the first video, we have seen how transaction internally works. We have understood what is Spring transactions, and we have also seen various examples in order to understand that. So you can go ahead and check this particular video over here. In the second video, we have seen transaction managers, which is again a core component of Spring transactions, and we have understood declarative and programmatic approaches of Spring transactions, and we have understood it along with examples. Now in this particular video, we are going to look into transaction propagations and various type of transaction propagations, and we are going to understand them along with the examples, right? So this is going to be a fun video, so sit back, relax and enjoy the show. So this is something which we have already checked, Spring transactions and transactional annotation, right? So in the first video, we actually understood what is Spring transaction and how it internally works. We have seen ACID properties as well. After that, in the second video, we have seen transaction managers, we have seen declarative and programmatic approaches. After that, in this video, we are going to look into transaction propagations, right? So these are all the type of transaction propagations that we are going to look into, and we are going to understand them one by one along with examples, right? Right, so first let's discuss what exactly is transaction propagation, right? So as the name suggests, how the transaction should be propagated to other method, right? That will be decided by your transaction propagation, right? So transaction propagation refers to how transaction behave when a method annotated with transactional is called by another method that may or may not have transactions, right? For example, there is one method, let's say method 1, and there is another method, let's say method 2 over here inside your same application, right? These two methods are there, let's say, may or may not be in the same class, right? Let's say method 1 do not have any transaction, but method 2 have transactional annotation, right? Or rather, let's say method 1 have transactional and method 2 do not have any transactional annotation. Then in this case, what will happen? How the transaction of method 1 will be propagated to method 2? Do method 2 needs any transaction? If it does not needs, then what exactly needs to be done? All these things will be handled by propagation inside your transactional annotation. Okay, so this is how Spring handles the propagation from method 1 to method 2 depending on your use case, right? So depending on what you exactly want, we can give the propagations on the respective methods according to your scenario, and we can get the task done, right? So that is when these type of transaction propagations comes into picture, right? So without wasting any time, let's jump into the code directly. So here, this is basically the application that we have been using. So same application we have used in last two demonstrations as well, along with the AOP videos. So this is basically a book application. In book controller, we have ample amounts of APIs that we have. And apart from the book controller, we have book service over here, where we have ample amount of functions over here, right? And this is basically annotated with @service annotation. And this service have add book method, which have transactional annotation on top of it. So in last videos, we have demonstrated transactions on add book function, right? So in this video also, we will start with that one only, right? Now, this particular add book function is annotated with @transactional annotation, right? Now we do not have any propagation over here, right? We do not have any propagation, right? So what propagation will be there? So if you do not add any propagation, then the by default propagation will be required. So required is a default propagation. That means if method A is calling method B, which is transactional, then transaction is required on method B. And this particular transactional annotation will start a transaction, or if the calling method already have a transaction, then same transaction will be propagated over here. Before that, what we will do, I will add a propagation over here to demonstrate how we can add a propagation. So here in transactional annotation inside bracket, you can just say propagation and you can say propagation dot required. So when it comes to required, you need not mention it because it is a default one, or even if you mention it, it does not matter basically. Now, if I go into propagation, we will see enums, right? So we have these many enums, and these are various type of your propagations basically. So we have all kind of propagation over here: required, supports, mandatory, requires new, not supported, never, nested, right? So all those type of propagations we have over here. Now what will happen in required? So basically, when it comes to propagation required, it means that this particular function requires a transaction. So basically, if the transaction is already active, it will join the same transactions. Okay. Or if we do not have transaction in a calling method, then it will start a new transaction. So who is calling this method? Our controller is calling, right? So controller method do not have any transactional annotation on top of it, right? So here we have this particular method, right? Add book. So add book is a method which do not have any transactional annotation. So when add book is calling your book service dot add book, there will not be any transaction, right? So basically, now if we don't have any transaction over here, then our add book will start its own transaction because it is a propagation is required over here, right? Or another scenario is, let's say if this particular add book will have a transactional annotation, let's say. So this add book is having transactional annotation, then this will start a transaction, and when it will call book service dot add book, the add book will join a same transaction which was started by your controller, add book inside controller, right? So that is the two scenario that we can look into here. So let me remove this transactional for now because controller do not really need a transaction. Now let's run this code and let's try to visualize what exactly is happening behind the scene. So what I will do, I'll pull up my Postman. So there we go. This is my Postman, and let me find a add book. Basically, this is a get book. Let's see if we have add book. We have this particular add book over here, and let's start our application in debug mode first because it may not be running in debug mode. So let me stop and rerun, and let's see what happens now. Now what I will do, I'll just add a debug point over here, right? And what we will do, we will add a debug point. We already have a debug point over here in the controller. Now what I will simply do is I will just hit the API. The moment I hit that, we hit the controller. So this is basically the controller over here. Now at this point, what we can do over here is we can go to evaluate expression and we can just check for the current transaction. What current transaction we have over here. That is something we can do by using transaction aspect support dot get current transaction. So let me do that. So what we can do is transaction aspect support dot current transaction status we can get. And when we do evaluate, we can see that no transaction aspect manage transaction status in scope. So it is throwing no transaction exception. That means there is no transaction ongoing basically when we are at this particular point, right? Now what we can do, let's move ahead. We will move ahead and now we are in service. Now there are 16 hidden frames over here. So let's go into threads and let's see what is happening. Now here, can you see? So here we have book controller. Right now it is trying to call book service, but it is calling proxy, right? Proxy and all I have covered as a part of AOP video. So you can go ahead and check this particular AOP video. So you will have a clear understanding of how AOP proxies work, right? So we'll create a CG LIB proxy over here, right? After that, it will say invoke within transaction. This is basically invoke within transaction method of your transaction aspect support, right? Which will be handled by basically your transaction managers. Now here, if you see, while it is starting the transaction, now just before proceeding with this invocation, what it is doing, it is creating a transaction over here, right? So in same invoke with transaction method, we have create transaction if necessary, right? So if I scroll to right, you can see transaction attributes. So what attributes we are seeing now? We are seeing propagation required. That means the propagation of this particular transaction is required, right? And isolation is default. So isolation is something which we are going to cover as a part of future video. So something to keep in mind that we are going to look into. So propagation is required over here, right? So now when we go to our this particular method over here in the book service, and now let's try to evaluate this particular expression over here. Let's say transactional aspect support dot current transactional status and evaluate that. Let me expand this guy a bit. Now you can see that it's a new transaction which is true, right? And we have this JPA transaction manager over here. That means this particular method have a new transaction running. So that is basically required for us, right? So when to use required? So basically whenever you need something inside transaction, you just go ahead and annotate it with @ transactional annotation and leave it, right? because default is required only. You need not specify it explicitly. You just say that, okay, transaction we want in this particular method, just mark it as transactional and you are done, right? So as simple as that. Now when it comes to other type of transactions over here, where is our list? Yeah, here. When it comes to other type of propagation, you explicitly need to mention it, okay? And in what cases you need to cover those, that also you need to keep in your mind, right? So required is something which is very straightforward that we have seen, right? So before we go ahead and start looking into requires new propagation, before that I want to specify a specific scenario as well. So let's say, so required we have seen, right? So here transactional is annotated and it is starting kind of a new transaction here, because the calling method of this function is not a transaction. But what we can do is, what I can do for demonstrate, I will make this as a transactional now. Okay, so I have added a transaction on add book as well now, right? So now when we hit this particular API, let's hit that. Now here we are in controller, right? Now let's see if we have a transaction over here. So what we can do over here is transactional aspect support, current transaction status. And now when we evaluate, we can see that there is a transaction, and the transaction is a new transaction because it just started basically, right? The methods before that do not have any transaction, and as we have a transactional annotation over here, the new transaction is started over here. Now when we move ahead, now we came into service, right? Now we have required over here as well, right? Now let's see what kind of transaction we have over here. Now what we can do again, transactional aspect support dot current transaction status. Now let's evaluate. Now as you can see over here, new transaction is false. That means this function is joining the existing transaction which is coming from the calling method, which is kind of a method inside controller, which is this one. In this case, add book, right? Because we have this @ transactional annotation over here. That means this is joining the same transaction. This is not creating a new transaction. So basically this was the scenario that I wanted to mention over here. Now let's move ahead. Now that is required for us. We have seen required. Now we will go ahead and start looking into requires new, right? So simply to put it in code, we just need to add a requires new over here and the job is done, right? But the code and all is fine, right? We can add it and it will create a new transaction. But why we need to create a new transaction? That is the question, right? So basically we use requires new propagation whenever we want to isolate a particular transaction from other surrounding transactions. For example, we can use requires new while we are doing logging or auditing for certain cases, right? Or whenever we want to perform some independent operations which are isolated from your existing transaction. The famous example of that would be sending a notification, right? You are doing certain task, but you want a notification to be sent to client in a different transaction. That is something you can handle inside requires new, right? Or the another famous example where you can use requires new is basically whenever you want to implement a retry mechanism, right? Each retry should happen in a new transaction. So when you want to ensure that, you can go with requires new, right? So that is when requires new comes into picture. So what requires new will do? It will suspend the existing transaction which is coming from your calling method, and it will start a new transaction over here, right? Now we have made this code change. Now what we will do, we'll just restart our application and let's see what happens in this case, right? So our application is restarted, and now let's go ahead and hit this API again over here. I'll say send. Now we are in controller, right? So controller over here would have started its own transaction because we have annotated it with @ transactional annotation, right? To check that again, we can do transactional aspect support dot current transaction status. When we evaluate, we will get that a new transaction is true. That means this guy over here started a new transaction for us. Now when we move ahead and come to service, now we have requires new over here, right? Now let's evaluate and let's see what is happening. Let me remove this. Let's say transactional aspect support dot current transaction status, and let's evaluate. Now can you see this? Now new transaction is again true. That means it is not joining the existing transaction that we have, rather it is creating a new transaction over here. So this will be executed inside a new transaction. Now if we can see over here, we can go ahead and check these frames over here. So here, if you can see, whenever it is starting a transaction, create transaction if necessary, you will see that propagation is requires new. That means it is using a new propagation that we have given over here, because we can see over here that propagation is requires new, right? That means if the propagation is requires new, it will always start a new transaction while invoking that particular method. Now requires new also we have covered, right? So required and requires new, both of them we have covered, right? So let's proceed and let's look into mandatory next. Okay, so mandatory is another transaction propagation type, right? Now let's try to implement and let's see what exactly it is doing for us. Now implementation is again straightforward, just say mandatory and you are done. Now when we say propagation as mandatory, it enforces that there should be an existing transaction present in the calling method. That means this function should not start any transaction, rather the calling method of this add book method should already have a transaction. That means who is calling this method now? Our controller. And if let's say this calling method do not have any transaction, then this add book will not start any transaction, rather throw an exception that there should be an active transaction present in order to propagate that particular transaction over here, because we are giving propagation as mandatory, right? This particular mandatory propagation is useful when you want to enforce that there should not be any new transaction created, rather things should work inside the existing transaction and there must be a existing transaction present while someone is calling this particular method, right? This is basically enforcing the existing transaction present. So in such scenarios, you can go ahead and use mandatory. This guy will not start a new transaction, rather use existing transaction. And if you do not have any existing transaction, it will throw an exception, right? So let's restart our application and let's see how this goes now. Now this is started. Let me hit this. Now we are in controller. Now this would have started a new transaction. Now let's move ahead and let's try to evaluate and check what kind of transaction we have over here. So what we will do, transaction aspect support dot current transaction status. Let's evaluate. And as you can see, it is not starting a new transaction, rather it is using the existing transaction. It is joining the existing transaction basically, right? What else we can do is let's see. So what I will do now, I will remove this particular transaction from this particular method inside the controller. Now this calling method do not have any transaction, but our friend over here is saying that I want a mandatory transaction which is coming from a calling method. Now let's restart this and let's see what happens in this case. Now our application started again. Let me send this. So here we are without any transaction. Let's go to our method. It caught an exception, right? Caught an exception. Now let's proceed and let's see what exception it caught. Might have propagated over here. Now if we go ahead and check the console, let's see what is the exception. Can you see over here? It says illegal transaction state exception. No existing transaction found for transaction marked with propagation mandatory, right? So this is what it will throw, illegal transaction state exception if you don't have existing transaction, right? Because this guy needs an existing transaction, right? If you do not have the existing transaction, it will throw. Or whenever you want to enforce that certain methods should be called from other methods transaction only and should not create its own transaction, then mandatory is something which is best for you, that particular case, and that propagation you can directly use over here, right? So that is mandatory for us, right? So mandatory also we have seen. Required over here is done. Requires new also we have covered, and mandatory also we have covered by now, right? So let's go ahead and see nested next. Okay, so what we will do over here, what we can do is we can change this to nested, right? And the calling method also we will go ahead and add a transactional over here so that we have existing transaction, right? So whenever you mark a method as transactional with propagation as nested, that means if the calling method have a existing transaction, then this method will run in same transaction in a nested way. Okay, I'll explain that what that means. And if the calling method do not have any transaction, then this behaves like a required, right? So it will start a new transaction basically. So it will behave like a required. But in this case, we have the transaction from the calling method, right? What it will do, it will join the same transaction, but it will run it in a nested way. That means it will create a save point at that point. Okay, it will create a save point, and this function will run in a transaction ahead of that save point. Okay, and if in this function there is some exception that is occurring, only that particular transaction after that save point will be rolled back, and the existing transaction before that save point will not be rolled back. So nested is basically useful when you want to do a partial rollbacks, right? Only roll back this function and do not roll back the entire transaction. In those cases, nested will be used. This is mostly used when we have to handle kind of an independent error handling mechanism. In those cases, you can roll back that particular transaction. So nested also we have seen, if you do not have the existing transaction, it will work as required only. So this one again will come into picture. Now we have seen nested. Now let's see supports, right? So supports, again, what we can do over here, we can convert this to supports, right? So supports is basically very simple. Okay, so supports means this particular function will support a transaction if the calling method have transaction, right? That means if the add book inside controller have any transaction, then this guy over here supports will have a transaction. Otherwise, if calling method do not have any transaction, then add book also will not have any transaction. If we have a transaction in calling method, then we will have a transaction over here. If we do not have a transaction in calling method, then we won't have a transaction over here. Now, in order to check that, let me restart the application and let's see what happens over here. So in this case, we have a transactional annotation in our controller. Now let me send it, and in the service, what we will do, we'll just evaluate. And when we do evaluate, it will say that it is under a transaction and it is not starting a new transaction, rather it is joining the existing transaction. Now the other case we can see over here is we can go ahead and remove the transactional annotation from this guy over here. That means the calling method is non-transactional. Now let me stop and rerun the application and let's see what happens. This has started. Let me hit this particular endpoint. Now we don't have any transaction over here. Now we will proceed, and in here what we can do, we can again evaluate and say transactional aspect support dot current transactional status. When we evaluate, transaction is equal to null. That means there is no transaction basically, and this guy over here is not starting in any transaction, right? Now supports also we have seen. Now only not supported and never is remaining, right? Now let's go ahead and check not supported next, right? So here not supported. So this is how you can implement propagation not supported. Just mention it over here and you're done. Now not supported means if the calling method have existing transaction, then for this particular method only the transaction will be suspended, right? And after this particular method, the transaction will be resumed again. That means this particular function will not run inside any transaction. It will suspend the transaction over here and resume it after the execution of this particular function. So the usage of this guy is straightforward. Whenever you don't want any transaction and you want to skip the transaction for certain methods, you can do it. For example, let's say you are calling a third party, right? You're calling a third party REST API or doing a REST template call and getting a data or sending some notification. Then in that case, you don't want that to happen inside a transaction. You don't want your function to wait for the response. What you can do is you can mention that particular function only in not supported propagation of that particular transaction, and the transaction will be aborted for that particular method. Now let me rerun the application and let's quickly check what is happening over here. So application started. Let me send this again. Now this guy will not start any transaction basically. So if it is not starting here also, you don't have any transaction, right? So we will quickly check though. Transactional aspect support dot current transaction status we will do and evaluate. So transaction is null basically. So what we can do is we can go into controller again and add a transactional annotation over here so that we have existing ongoing transaction. It is started. So let me send it again. And here in the service, let's again evaluate what is the status of transaction. So transaction aspect support dot current transaction status should be null again, right? It's basically again null. Now, not supported also we have covered. Let's go back here and let's see. So this again is done. Now the last one remaining is never. Right. Now again, how to implement? Just go and do never. Now, as the name suggests, never means that this particular method should not run in any transaction. If the calling method of this particular method have a transaction, then this method will throw an exception saying that there is already ongoing transaction and I don't want transaction basically. Right. So in order to check that, let me stop and debug. Let me restart. It is restarted. Let me send it again. Now here the transaction will be started. What we'll do? We'll proceed. And can you see? It is catching an exception. Now let's see what exception it is throwing. Expand this. Let me scroll up. Again saying illegal transaction state. Saying existing transaction found for transaction marked with propagation never. That means I don't want any transaction and you are calling me with a transaction. So that is what it is trying to say basically. Now the moment I remove this and rerun this again and let it come up. So it is started. Now let me send this guy again. Now here we don't have any transaction. Now when we proceed, now it is being invoked fine, right? Because we don't have any transaction and this guy don't want any transaction. So now it won't throw because the calling method do not have any transaction. Now this will just work fine, right? Never you can use in cases where you want to do a monitoring of your application. Let's say there are system health check functions which you want to exclude from transaction or monitoring functions which you want to exclude from transaction. Right? For those cases, you can go ahead and use never. So never also we have seen, right? So I will mark that as done now, right? So that is how you can make use of all the transaction propagations inside Spring transactions, right? And for different use cases inside your application, you can use different transaction propagations, right? Now that marks the end of it. We have covered all the transaction propagations, right? Now what is next? So basically we have covered transaction propagation as well. We have covered transaction managers. We have understood transaction before that. So third part of transaction is done basically. Now next is isolation levels. So isolation levels will be the final part of transaction. Again, very important aspect of Spring transactions. So that marks the end of this particular video, transaction propagation. Hope you have a fair understanding of transaction propagations by now and you know how you can make use of various different transaction propagations inside your application. Now if you like the video, hit the like button. Don't forget to subscribe Code Snippet. Share this particular video with your friends so that they also have an idea about transaction propagations and how transaction works. That's it for this video. See you in the next video.